Dear children, today we are going to start a new chapter, Unit 6, Thermodynamics. This thermodynamics is a very, very important chapter. All of us know that in almost all the physical and chemical processes, energy change take place, isn't it? Sometimes, the energy changes accompanying a chemical reaction is rather more significant than the reaction itself. For example, when LPG is burned in the kitchen, we don't bother about the products of the reaction. Similarly, when coal is burnt, the energy of the combustion becomes more significant to a common man than the product of the reactions. Second thing we must understand that the energy changes during a chemical reaction is not just released in the form of heat. Okay? The energy of the chemical reaction can also be manifested in the form of electrical energy, work energy, light energy, sound energy, etc. Now I'll just give you a few examples. Suppose we burn coal, cooking gas, wood or anything, that the chemical reaction takes place and the chemical energy is released in the form of heat only, okay, or to some extent to light. When magnesium is burnt in air, then the chemical energy is manifested in the form of heat and light. When the petrol is burnt in the internal combustion engine, then the chemical energy is manifested in the form of mechanical energy and heat. When the redox reaction is taking place in a galvanic cell, then the chemical energy is converted into electrical energy. So you can see that when chemical reactions take place, the energy change also takes place, and this energy change which take place is manifested in the form of heat, light, sound, electrical energy, etc. Now the question is, why should there be any change in energy? Well, we know that during a chemical reaction, the old bonds are broken in the reactant molecules and the new bonds are formed in the product molecule. We also know that in order to break the bonds, energy is needed, and when the new bonds are formed, energy is released. So, whether the chemical reaction is endothermic or exothermic, that is, whether the chemical reaction requires energy or whether the energy will be released during the reaction, that depends upon the nature of the bonds to be broken and formed. Now let us discuss thermodynamics now. Thermodynamics, the term thermodynamics was given by a mechanical engineer. As we know, thermodynamics literally means thermodynamics consists of two parts. Therm refers to heat and dynamics refers to movement. So basically, thermodynamics means the conversion of heat into work and vice versa. But nowadays, the term thermodynamics is used in much wider sense because it deals with almost all forms of energies. So thermodynamics is very much relevant in physics, chemistry, engineering, biology, and so on. Now thermodynamics may therefore be defined as the branch of science which deals with the quantitative relationship between the heat and other forms of energies. Okay? So this is the definition of thermodynamics. What is thermodynamics? Thermodynamics is a branch of science which deals with the quantitative relationship between heat and other forms of energy. Now when The study of thermodynamics is limited for chemical processes. It is referred to as chemical thermodynamics. Okay, so we are going to apply the principles of thermodynamics in chemical processes. The study of thermodynamics is based upon three fundamental generalizations which have been arrived at purely on the basis of human experiences. Now these human experiences or generalizations are called first, second and third laws of thermodynamics. Now you will ask me that the generalization cannot be called the laws. Yes, you are absolutely right. These are the human experiences, but nothing contrary to these generalizations have been reported so far, and that is why these generalizations are called the laws of thermodynamics. Is it clear? Now, in addition to the three laws, there was another generalization which put forth at a later stage, and this came to be known as zeroth law of thermodynamics. Okay, so basically there are four laws of thermodynamics: zeroth law, first law, second law, and third law of thermodynamics. Now the question is, what is the need of studying thermodynamics? Okay, what is the importance of thermodynamics? So let us discuss the scope and limitations of thermodynamics. Well, thermodynamics help us in predicting the feasibility of the chemical reaction under the given set of conditions. Okay, so these are the advantages of thermodynamics. Number one, the thermodynamics help us to predict the feasibility of the chemical reaction under the given set of conditions. It means thermodynamics is going to help us whether a particular reaction will take place under a given set conditions or not. That can be predicted with the help of thermodynamics. The second, thermodynamics help us in predicting the extent to which the chemical reaction can occur before the equilibrium is attained. So not only thermodynamics help us in predicting whether the reaction will take place or not, thermodynamics will also help us in predicting the extent to which the chemical reaction can occur. So these are the very important advantages of studying thermodynamics. Then, what are the limitations of thermodynamics? Well, thermodynamics have few limitations. Thermodynamics has few limitations also. Number one, that the thermodynamics does not tell anything about the speed or rate of the reaction. Okay, as I have already told you, that thermodynamics certainly helps in determining, in predicting whether the chemical reaction will take place under the given set of conditions or not. But thermodynamics does not tell anything about the rate of reaction, and for that we have to study the separate branch of chemistry, and that is called chemical kinetics, which you have to do in class 12. The thermodynamics also does not tell anything about the mechanism or the path of the reaction. Okay? We will see later on that thermodynamics deals with the initial and final states of the system. Okay? So thermodynamics only talks about the initial state and the final state. It does not tell anything about the path, that is the mechanism of the reaction. And the third limitation is that thermodynamics does not tell anything about the individual atom or molecule. Why? Because thermodynamics always considers the matter in bulk. Thermodynamics talks about the system, and the system consists of a collection of atoms or molecules. But if we want to know about the individual atom or molecule, then thermodynamics cannot tell anything about the individual atom or molecule.